We will be talking in this video about why it's so important to compute limits when it comes to calculus. Okay, at least a few of the important type of limits we are going to be looking at. All right, so until calculus, really, what do we know? What kind of functions can we handle? Really, it is the linear functions and the quadratic functions. So let's look at the function. Let's call it f of x. That's x over x minus 2. All right. Let's see how would we try to graph this function. Okay. So first of all, whenever you have to deal with a function, the first thing we should look at in order to try and understand it is the domain of the definition of this function. Well, this function is actually a fraction, and the denominator of it contains the variable x. So we want to make sure that we do not divide by 0, so x has to be different from 2. All right, so if we want to write the function as it should be, we should say the function f is defined on the set of real numbers minus the point 2 with values into the set of real numbers. All right, now given this, so we have to take away 2 from the domain of definition of this function. In order for us to do so, what we want to do is we want to mark the point 2 on the x-axis, and we want to draw this vertical line that we are going to refer to as the vertical asymptote. Okay, and so what this means is that our function is allowed to sort of approach 2 from left and from right, but we will never take the value x equals 2. All right, but okay, so we do not take the value x equals 2, but we should understand the behavior as we approach 2 with values of x. So really what we need to do is we need to compute this side limit. So we need to understand what happens with the value of f of x when we approach 2. Well, and when we have a minus here from the left, right? So where we want to figure out the value of f of x when we approach 2 from left. So this is a side limit that we need to understand. Okay. Also, we want to understand what happens with the value of f of x when we approach 2 from the right. This plus means that we approach 2 from the right. Okay. So we need to be able to compute side limits in order to understand the behavior of f as we approach x equals 2, so as we approach the vertical asymptote. Okay, so that's one very important type of limits we are going to be looking at. Also, what happens when x approaches minus infinity, or what happens when x approaches plus infinity? Is our function going to go up towards plus infinity or minus infinity? Is it going to approach a certain value? We don't know that yet. So what we need to do is, again, we need to compute limit from f of x when x approaches plus infinity in order for us to understand what happens with the graph of f in the neighborhood of plus infinity. And we have to do the exact same thing for minus infinity, so we need to compute the value of f of x, the limit when x approaches minus infinity of f of x. Okay, and these values will give us potential horizontal asymptotes. Horizontal asymptotes are when the horizontal lines that a function may approach when x approaches plus or minus infinity. In this case, it will turn out that there is a horizontal asymptote. We are going to deal with that in the near future, but for now, just because we mentioned this idea of horizontal asymptote, this function will have a horizontal asymptote which is x equals 1, y equals 1, both at plus infinity and at minus infinity. Okay, or it could be the case that maybe certain functions will approach a known function like a line when it goes to plus or minus infinity, and that will be called a slant asymptote. But regardless of those details, fact is that we need to compute limits in order to understand behaviors of functions at plus and minus infinity. Alright, so now we figure out what we need to do when we approach points that are excluded from the domain of definition of our function. We kind of figure out what we need to do when x approaches minus infinity and plus infinity. Well, what happens in between? Because really we didn't deal with that many points yet. Okay, so a very important thing would be to know when a function is an increasing function and when it is a decreasing function. Well, so let's say this is a point x and this is a point x plus h on here. Okay, we want to know whether a function is increasing, let's say, around x. In a previous video on the monotonic functions, we figured out that actually the quantity to look at when we want to deal with a function that's increasing or decreasing is us looking at this quantity, f of x plus h minus f of x over x plus h minus x. Alright, so this was the crucial quantity to look at when it came to us figuring out whether a function is increasing or decreasing. Alright, now these 2 points are 2 points far away from each other. So even if we know that maybe a function, let's say, decreases in between x and x plus h, who knows what happens in between? Maybe you have some oscillating type of behavior. Okay, so this fraction is really important to look at, but actually what we want to do is we want to look at the limit when h approaches 0 of this fraction. Okay, and in the case that we have a nice enough function for which this limit exists, okay, this limit being positive will tell us that the function actually increases around x, and this limit being negative will tell us that the function decreases around x. Alright, so this type of limit is very important towards us figuring out if a function f is increasing or it is decreasing. Alright, so the bottom line is that in order to figure out more and more details about this function, we need to be able to compute a bunch of limits.